Hello again. This is Math 2231 coming to you from the College of DuPage. And the title of this lecture is Rectilinear LSA Solution. As always, be an attentive learner while watching this video. So recall, in this problem dealing with rectilinear motion, that is motion in a line, that I gave you a graph. And the graph showed the velocity in feet per minute of a particle moving back and forth along a horizontal axis for 10 minutes. Now that means this is velocity and this is time. So use the graph and your knowledge of calculus or physics to answer the following questions using correct units. And I did cover enough of the physics for you to be in good shape with this, as well as the calculus. And here are the questions that I ask you. What is the velocity and acceleration of the particle when t equals 1 minute? Part B, assuming that the particle started at the origin at exactly 10:13 a.m., at what times did the particle change direction? Your time should be exact, using seconds if required. Part C, and again assuming a start at the origin, what is the location of the particle at time t equal 10? Part D, what is the average velocity and average acceleration of the particle on the interval from 0 to 10? And finally, Part E, at what time or times is the particle the farthest from the starting point? And how far away from the starting point are you? And you should explain your answer. And again, the graph is shown here. Now, if you've done this, congratulations. If not, spend some time thinking about it before you proceed. Let's see how you did. On part A, where we defined the velocity and acceleration when t equals 1, recall that we have this is the velocity and this is time. And so the velocity is going to be, you just go onto the graph and say at 1, you are at 15. And we know that that is a straight line between 0 and 30. That was the change in y. And so the average velocity is going to be 15 feet per minute, because that is what you get when you plug in the 1. Now the acceleration is the change in velocity, and that is going to be the change in velocity. So it's 30 here, and it was 0 here, and so it's the slope of the line. And so acceleration equals the slope of the segment joining 0, 0 and 230. Again, the slope of that segment upon calculation is 15 meters per minute squared. And the velocity was 15 feet per minute, again, including units. Part B, recall, said, assuming the particle started at the origin exactly 10:15, at what times did the particle change direction? And your time should be exact, using seconds if required. Well, what you should notice is that whenever the velocity is positive, you're moving to the right. When the velocity is negative, you're moving to the left. So you see you're going in a positive direction until you cross the t-axis. And then you're going in a negative direction for a while until you cross again, and you cross again here. Now all of these are line segments, and so here you know this point and you know this point. And so what you can do is you can solve the equation to find what this point is, where it crosses the axis, where it changes direction. Again, these are line segments, and you know what the endpoints are, so you can find the equation of line and find out where this one hits here. So the points where on the graph it changes direction are here and here. And if you do the calculations and convert this to hours and minutes and even seconds, what you see is that the particle changes direction and we're starting at 10:13 a.m. and this is 5. So that is going to be, that's 5 minutes, so that is 10:18 exactly. And again, over here, this is at 10:22 and 40 seconds. Part C. What we're to find is, you start at the origin. What is the location of the particle at time t equal 10? Well, you see, what happens is we're having average acceleration, and so during these times you have average acceleration here, average acceleration here. We're decelerating here, and we're having all of these changes, but everything is a line segment. And so distance equals rate times time, and that means that velocity is going to equal the area under the velocity time curve. So the distance is equal to the area under the velocity time curve. So what we can do is we can say, well, so what happened? You started at 0 and you went 30 feet here, because that's the area of this triangle. The area of this rectangle is 60 feet, and the area of this triangle is 15 feet. So you're at 105 in the positive direction. But now what is happening? You're changing direction, so you're going the other way back. So the area of this triangle is 15, but it is a negative 15. This is a negative 5, this is negative 60, and this is negative 20 over 3. And then you're going in the positive direction again, and that area is going to be 5 over 3. These are the areas of the curve. And so we want to know, where do you locate? So you went 105 here in the positive direction, you went in the negative direction, and you went here. You have to add all of those things up, but you're adding signed numbers. Some are negative and some are positive. So what happens is, when you add all that up, you're 20 feet to the right of the origin at the end of the 10 minutes. That's the answer to part C. In part D, we're to find what is the average velocity and the average acceleration of the particle on the interval from 0 to 10. Well, you started at 0 and you finished at 20. So that means your average velocity, because this is velocity, 0, and you're at 20, and it took you 10 minutes to do that. So your average velocity, because some was negative and some was positive, is 2 feet per minute. It is 20 minus 0 divided by 2. In a similar way, the slope of the velocity curve, the change in velocity with respect to time, is the average acceleration. So the average acceleration is the slope connecting, and here you were at, and by the way, you're going at, your velocity is 10 here, your velocity was 0 here, so it is 10 minus 0 over 10 minus 0 time, so that is 1 feet per minute squared. And so that is the average velocity and average acceleration. Part E. At what times is the particle furthest from the starting point? And how far from the starting point is it? And explain your answer. Well, here you went, and you add these up, you're going in the positive direction. You start out going faster and faster, then you stabilize at a constant velocity there, still going in the positive direction, and then you start slowing down, but you're still going in the positive direction until this point. Well, when you add those up, you find that you're at 105 at t equal 5. Now, you still don't know that that's the furthest away, but then you say, well, how far do you go in the other direction? And you add up these, and you find out that these blue numbers are less than that, and then you start going back in the positive direction just a little bit. And so the answer to this is, the furthest your way is 105 at time t equal 5. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself, because self-care is important. And take care of each other. We're all in this together. God bless you all.